So a jeweler resizes a ring so that its inner circumference is 6 centimeters. Then we're asked a bunch of questions, and I put from the get-go to round to 4 decimal places throughout, just so we're all doing the same thing. Part A, what's the radius of the interior of the ring? So let's see what the question was, or what we were given. Again, a jeweler resizes a ring so that its inner circumference is 6 centimeters. So circumference is 6. What's the radius? So circumference, again, was 6 centimeters. We're not going to have to worry about the units, but... And then what is R? All right, well, what's the equation for the circumference of a circle? Yep.
2 pi r.
Good, 2 pi r. All right. So this is actually real easy. We just go ahead and set 2 pi r equal to 6 and solve. And we're told to do this to 4 decimal places, so we're not going to write it exactly. We're just going to go ahead and round this to our 4 places. We have r is equal to 6 over 2 pi, 3 over pi, and now let's round it off, 0.9549 to 4 places. Questions there? Okay, part B, if the ring's inner circumference can vary between 5.5 centimeters and 6.5 centimeters, how much can the radius vary? So this is a little tricky in that the units of the circumference and the radius are the same. Before we could use the units to kind of help us navigate what was, if we're talking about volume or was it a length. So we got to be really careful here. Again, the ring's inner circumference can vary between 5.5 and 6.5. So they're talking about the circumference there. How much can the radius vary? So I think it's helpful to write down what was given in inequality form. So the circumference can vary between 6.5 and 5.5. And we want to know what the radius can vary between. So since we have the circumference formula that's in terms of the radius, we can do this with this inequality we started with. So C is equal to 2 pi r. Just plug that in for C. And then now we have a compound inequality that we can just solve for r. And that's the answer. So we're doing this again, correct to 4 decimal places. So we'll actually just take the 5.5 divided by 2 pi. And we get 0.8754. 6.5 divided by 2 pi is about 1.0345 to 4 places. So that's it for part B. Questions there? Yep. Don't worry about that. So the question was, do I have to worry about whether it's an equal sign underneath or not? I'm being kind of sloppy about it myself probably. So we won't be real precise on that. Good question though. So vary between, what I'm saying is strictly I should probably have without the equals here. So I'll just get rid of those now that I realize I was being sloppy. But yeah, you won't have to worry about that for the test. If you're a little sloppy with that part, it's okay. Other questions? Okay, part C. I'll just read it to you. It says, identify delta and epsilon from the precise definition of a limit. All right. So I have that precise definition there, which just got off the page. So let's just start working on this a little bit. Usually the epsilon is more obvious because you're given the epsilon or something that deals with it. So let's write down that stuff. The absolute value of f of x minus L, its absolute value is less than epsilon. So our function in this case that relates like the x and the y is the circumference. And then the circumference that was like the ideal circumference in the problem setup was 6. We're supposed to have a circumference of 6. And we're told that the circumference can vary between 5.5 and 6.5. And that was from part B. So we just need to put some things together here to determine epsilon. So notice that with this absolute value of c minus 6, I'll just write it that way, is less than epsilon, that we can get that from being told what the circumference can vary between. So the way we start working on this is to subtract 6 everywhere. And that's how we get the c minus 6 in the middle. And then let's see what we get on the tails. So take 5.5 minus 6, and you get negative 0.5. C minus 6 in the middle, and 0.5 on the right. And now, usually we're doing this step the opposite direction when we went over the algebra review, but notice that we have a negative and a positive and they're the same value. So we can repackage this up as the absolute value of c minus 6 is less than 0.5. Or if you don't want to be fancy with the notation and stuff like that, you can just note that if, okay, hold on, let me finish the problem before I get too off on a tangent here. So epsilon is equal to 0.5. Let's just state the answer first before we get distracted. So this is kind of using that precise stuff from the definition, but if you just showed some work that basically said, well, I know the circumference varies between 5.5 and 6.5. Ideally, we want 6, so I just take the difference of each of those n values with 6, and that value on both sides is going to be 0.5. You can just show some work that does that, and that's totally fine. You don't have to use all this notation. Let me see what my time is. Okay, we're doing good. So we have to find delta, but any questions about epsilon? So we're going to do delta in a similar way. So from the precise definition, we have, so let me just say this is for delta. The absolute value of x minus a is less than delta. So with this little word problem application thing, what was our x? Because there wasn't actually x in this problem. We identified that f of x was the circumference. What was x in this problem? Or like our input variable, independent variable. Circumference depended on radius, and we're asked a bunch of questions about the radius. Okay. And then the ideal radius was something we found from part A. And what we determined for that value is 0.9549. So I'm going to write that together now. that for this problem, our x minus a is r minus 0.9549. What we also determined from part B was what the radius could vary between. So what we got was that the radius was between 1.0345 and 0.8754. That was just our, whoops, ran out of room. Let me just write it left to right. 0.8754, 1.0345. All right, so taking the same or similar approach that we did with the last one, because we know the ideal radius, you can just subtract that from the values that the radius can vary between, make it positive if it's negative, and then those are our candidates for delta, and we take the minimum. That's what you need to do. How you show that is sort of up to you here, but make sure you are showing some work. So I'm really good. I'll do it the legit way over here, kind of like I did for epsilon. So I subtract that ideal radius, which is the 0.9549, everywhere in this compound inequality. And what do we get after we do that? We get, on the left-hand side, negative 0.0795 to 4 places. And on the right-hand side, we get 0.0796. And so, now normally this was the circumference was a linear function, but because we over-rounded here, or there's some rounding issues here, these values are not exactly the same. But in theory, they should be. So just take the minimum like we normally would, kind of err on that side. And so, okay, so absolute value is 0.0795. We're comparing these two. Take the minimum, which is the 0.0795. I'll write those notes about, well, I guess I'll do that now. So this is linear, so in theory the same, but should be the same. But a little different from rounding. So you don't have to worry about understanding that, it's just take the minimum. But I wanted to explain a little bit in case people are wondering. So then what we have is our R is less than, or R minus 0.9549. Absolute value of that is less than 0.0795, which is the delta. So the delta is 0.0795. Questions? Okay, I'm going to stop the recording. If you still have questions, that's fine.